Welcome to this lesson on significant figures, an essential concept in physics. When making measurements in science, precision matters. Significant figures help us express exactly how precise our measurements are. Understanding this concept will improve the quality and accuracy of all your physics calculations. Significant figures are the digits in a measurement that carry meaningful information about its precision. They tell us which digits we can trust based on how accurately we measured something. For example, if we measure a length as 12.50 centimeters, this measurement has 4 significant figures. Each of these digits provides information about the precision of our measurement. Let's learn the first 3 rules for identifying significant figures. Rule 1, all non-zero digits are significant, so in a number like 234, all 3 digits count. Rule 2, zeros between non-zero digits are significant. For instance, in 503, all 3 digits including the 0 are significant. Rule 3, leading zeros are not significant. In 0.045, only the 4 and 5 are significant. The zeros at the beginning are just placeholders. Now for the remaining 3 rules. Rule 4, trailing zeros after a decimal point are significant. In 12.500, all 5 digits are significant because those trailing zeros show precision. Rule 5, trailing zeros in a whole number without a decimal point are not significant. The number 1500 has only 2 significant figures. Rule 6, trailing zeros with a decimal point are significant. If we write 1500.0, now we have 5 significant figures because the decimal point changes the meaning. Let's practice identifying significant figures with some examples. 123.45 has 5 significant figures because all digits are either non-zero or zeros between non-zero digits. 0.00456 has 3 significant figures. The leading zeros don't count. 100.0 has 4 significant figures. The trailing 0 after the decimal counts. 2500 has 2 significant figures because trailing zeros without a decimal point are not significant. When working with significant figures, we often need to round our answers. The rule is simple: round to match the number of significant figures required. For example, if we need to round 12.6789 to 3 significant figures, we look at the 4th digit. Since it's 8, we round up, giving us 12.7. This maintains the appropriate level of precision for our calculation. When multiplying or dividing measurements, the result should have the same number of significant figures as the measurement with the fewest significant figures. This rule ensures our answer doesn't claim more precision than our least precise measurement. For multiplication and division operations, count the significant figures in each number, find the smallest count, and round your final answer to that many significant figures. Addition and subtraction follow a different rule. When adding or subtracting measurements, the result should have the same number of decimal places as the measurement with the fewest decimal places. This makes sense because we can't be more precise than our least precise measurement. Look at how many digits come after the decimal point in each number, find the smallest count, and round your answer to that many decimal places. Let's work through a multiplication example. If we multiply 4.56 by 1.4, we get 6.384 on our calculator. However, 1.4 has only 2 significant figures, while 4.56 has 3. Our answer must be limited to 2 significant figures, matching the least precise measurement. Therefore, we round 6.384 to 6.4 as our final answer. Now for an addition example. Adding 12.11 plus 18.0 plus 1.013 gives us 31.123. But look at the decimal places. 12.11 has 2 decimal places, 18.0 has 1 decimal place, and 1.013 has 3 decimal places. Our answer is limited by 18.0, which has only 1 decimal place. So we round 31.123 to 31.1. Let's review the key points. First, significant figures reflect measurement precision. They show how accurately we know a value. Second, you must know the rules for identifying significant figures in any number. And third, apply the correct rules for each type of mathematical operation. Use the fewest significant figures rule for multiplication and division, and the fewest decimal places rule for addition and subtraction. Master these concepts, and your physics calculations will always maintain appropriate precision.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.